mates to join, and thereafter we can start off. Maybe 2 3 4 minutes we wait so that everybody is there with us and we can start thereafter. But let's see that we started maybe in another 2 3 minutes. Otherwise it would be difficult in this 1.5 hours time to cover what is intended to be covered. So keeping this in mind, let's wait for another. It is just 11:30. We will wait for maybe another 2 3 more minutes and wait for your friends to join. The minute your friends join, we start off with what we have to do. We are currently just 5 6 of us. We can wait till say 11:33. 2 more minutes. Let's wait for your friends to join, and thereafter we can start. Okay, since it's 11:33, we have waited for 3 minutes for your friends to join. Bari sir, can we start? Otherwise, we. Yeah. Okay. So I would once again say on the last day of 2020, we are having a class which with you wonderful students of ISL Hyderabad. We start off with our third or the fourth session with you guys. Today onwards, we will be covering module 2 for 6 sessions, which will be statistics for big data analytics using R and Python. Please understand, friends, before you do anything in big data analytics, you have to be wonderful with statistics. And as on today, there are just 50 statistical techniques that you need to learn for you to excel in this field of big data analytics. A small little say, if I could say something on this. See, we all know that this classical statistics focused exclusively on inference and sometimes complex set of procedures for drawing conclusion about you can say the large population based on small samples. So there was a gentleman somewhere in 1960s by the name of John Tuckey. He was called for a reformation of statistics, and he proposed a reformation of statistics in 1962. He said the simple plots like box plots, scatter plots, that along with summary statistics, that is mean, median, quantiles, help you to paint a picture of the data set. So keeping this in mind, let's start off with what are the few little understanding of yours of the concepts before we get into the practical part of it. You have to understand what are the elements of structured data. See, friends, we know data comes from many sources. You can have data coming from sensor measurements, events, text, images, videos, IoT, so many. So, when data comes out of all these things, the big question that comes in our mind is why should we bother about the taxonomy of data types? See, it turns out that for the purpose of this data analysis, which we are interested in, and definitely on the concept of predictive modeling, the data type is important, very important, I would say, to help determine the type of visual display, data analysis, or statistical model. And in fact, friends, data analysis softwares, which I would say, although you can use Java, but most preferred and which will overtake our old friend of Java is R, Python, and Julia. So, in fact, these data software, can I request you all to mute your microphone, please? Yeah, thank you. So the data science software such as this R and Python predominantly uses these data types to improve computational performance. And more important, the data type for a variable determines how software will handle computation for that variable. There are some key terms for data type which I will want to understand from you. Can you tell me what do you mean, what are the various key terms when you speak of data? What are the key terms? Can somebody help me out, please? Polier, somebody can help me out. Last day of 2020. So definitely somebody can help me out. Okay, I would say the key terms for data when the minute you speak data are data can be numeric or categorical. Numeric means data that is expressed on a numeric scale. There are two types of numeric data. It can be continuous data and discrete data. What is continuous data? Is the continuous data is the data that can take on any value in an interval. And various synonyms such as interval, float, numeric are also used to describe numeric data or sorry, continuous data. Then the second type of numeric data is discrete. Here in discrete, data can take on only integer values, such as you can say counts. Some synonyms like integer, count are used to describe discrete numeric data. Then we have categorical data. In this categorical data, data can take on only a specific set of values representing a set of possible categories. And categorical data is of two types. It can be binary or ordinal. This binary data is a special case of categorical data with just two categories of value, that is 0 and 1, or you can say true or false. Then we have also got ordinal data, which is a categorical data that has an explicit ordering. Okay, what we will do commencing today at the end of the session, maybe it would take about 1 2 hours after the session, I will share you a link. Which I, since although I have got all your email ID, it is difficult for me to share it with everybody. I would share it with your HOD on one link, one URL with a password from where you can download today's session. Because I'm recording this session, you will get a first hand feel of this complete session. But the link which I provide to you, it will be available only till 10 o'clock in the night today. So in that interim, if you are able to download, it is great. Otherwise, it vanishes. Dot at 10, the link would vanish. Nobody would be able to download. Even I won't be able to do anything for you. So kindly you make sure that you are able to download the complete session, which will be as a MP4 file. Okay, so I said there are two type data can be you can use two important terms when you're speaking of data. You can say data can be numeric or categorical. Numeric, we have got two types of numeric data. It can be continuous or discrete. Categorical, there are two types, which can be binary and ordinal. So knowing these small little terms will definitely help you when you go ahead with this for doing anything with big data analytics. Another one very important thing, the typical frame of reference for an analysis in data science is that it considers data in a rectangular format. Can you give me an example of a data in rectangular format? Anybody? Anybody can please tell me? So for which I'll have to, or do you want me to go back in the screen and ask you by name? Anybody, since most of you have written your numbers, I really don't know who you are. Sayed Wali,
Table,
Shahab, please tell me. What do you mean
sir,
by data? Yeah, please tell me.
tables or array list.
You are half correct. I would say rectangular form of data can be a database table or a spreadsheet. That is, rectangular data is a data which is in the form of a two-dimensional matrix with rows indicating records and columns indicating features. And data frame is the specific format in which data is pulled in or taken by R and Python. Please keep these concepts exactly like this in your mind. So since we spoke of rectangular data, there are some terms associated with rectangular data. The first is, what is a data frame? Can somebody help me out with what is a data frame? Anybody, please?
Data frame, it's nothing but table itself, no, sir?
Yeah, you're
No.
right. But Syed, in slightly different words, you'll have to say data frame is a rectangular data like a spreadsheet, and it is the basic data structure for statistical and machine learning models. And then comes a very important term as features. What is a feature? Who can help me out? Okay, feature is a column within a table, which we refer to as features. A column within a table is what is a feature. Then is outcome. See, many data science projects involve predicting an outcome. That is, often it is yes or no, or the often it is yes or no. The features are sometimes used to predict the outcome in an experiment or study. Then the very important thing is records. What are records? Records are nothing but a row within a table is called as a record. So what you can do, you can take any kind of data. We understand one thing very clearly. In R, Python or Julia, data is accepted only in a rectangular format. And there are various tools in R, Python and Julia which converts or cleans up the data, removes the outliers, removes the nan values, converts the data into a rectangular format and feeds in the data. Now, since we said data is in a rectangular format, there can also be data which is in a non-rectangular format. So, what is this non-rectangular form of data? And some example of that, please. Who can tell me what is a non-rectangular data structure?
Trees, graphs.
No, see, that is also, see, it is a dichotomy where you can say yes, correct as well as wrong. See, I would say non-rectangular data structures are those structures which are not rectangular. Wonderful example is the spatial data structure, which are used in mapping and location analytics, and which are more complex and varied than rectangular data structures. Basically, in the object representation, the focus of the data is an object, which is maybe a house, and its spatial coordinates. The field view, by contrast, focuses on, you can say, small units of space and the value of a relevant metric, which can be pixel or brightness, for example, whatever these things. So, after we having seen this, let's understand some more basic things before we get going. What do you mean, or what is the difference between mean and average of any data? Tell me as a professional, please. I know all you students are wonderful students of ISL, and you will be able to answer. Please tell me, what is the difference between mean and average of a data, of a set of data, you can say. Friends, mean and average both are the same. It is the sum of values divided by the number of value. Just to confuse you, I use these two separate terms. It is both one and the same, mean and average. Then comes another term which is called weighted mean, which is the sum of all values times a weight divided by the sum of the weights. That is, weighted mean is the sum of all values times a weight divided by the sum of the weights. Then you got median, which is nothing but the value that is one half of the data lies above it, one half lies below it. Then the other term which you need to know is percentile, which is the value that lies below that. That is, see, in all the big institutes in our country, never is marks given as percentage or the CGPA or all these. How marks are calculated is by percentile. There's a big difference between percentage and percentile. Percentile is the number of people who are below you. Say some exam in this big data analytics is conducted for you, and the highest somebody scores is say 75. The person who scores 75, all your marks are compared with respect to the student who scores 75. That gives you percentile. After this is the concept of weighted median, which is the value such that one half of the sum of weights lie above and below the sorted data. Weighted mean is the value such that one half of the sum of the weights lie above and below the sorted data. Then you have got trimmed mean. Trimmed mean is the average of all values after dropping a fixed number of extreme values. That is, trimmed mean is the average of all values after dropping a fixed number of extreme values. Then the last thing what you need to know, last or the second last you can say, is robust. Robust is something which is not sensitive to extreme values, or you can say outliers. Something which is not sensitive to extreme values. Then you got outlier, which is a data value that is very different from most of the data. So till here, has anybody got any doubts? Please tell me.
No,
If
sir.
wonderful. So what we will do, we will continue with over here. Say I have got four values: 3, 5, 1, and 2. I ask you to compute mean. What will be the mean? The numbers are 3, 5, 1, and 2. Very, very basic. How will you calculate the mean? Samir, Shahab, Sadaf Naz, Conan, please tell me. These are some of the names which I can see in the list of students who are present here. I've got four numbers: 3, 5, 1, and 2. I want to calculate the mean. What is the mean?
Mean is the sum of the four elements divided by the
Okay.
number of elements.
Yeah,
So
that
it would
so
be
it comes.
11 by 4.
Yeah, that's very correct. This is the most fundamental which you should know what this thing is. And in the similar way, you please even find out the median of these numbers. Whatever you can. Now I will request you, let's get hands on with what we are doing. So let's exit this, and I will suggest please go back to our studio, where, and I hope you can see the R studio in front of you. What we will do, we will calculate the location estimates of population, and let me say the murder rates. I'll give you a small little data set of US states where the population, and the other thing what is mentioned is the number of murder that go on over, the crime that goes on in that city. So I will request you, please open a Excel sheet, a Excel file, a small little data set, maybe of 7 8 rows. We can chart it out in this, and we will use this data set. So like in front of you, I have clicked open my Excel, and the Excel sheet is open, and I presume you must be able to see it. I have blown it up. What we will do, the first column header, I give it the name state. The next, let me call it population. The next, let me call it murder rate. And the last, not that, that's enough. These three are more than enough. Three columns: state, population, and the murder rate. And what we will do, let's take, say, the various Indian states. Let me say the first we take Hyderabad, then I take Bangalore, then I take New Delhi, then I take Mumbai, then I take Chennai, then I take Kolkata, then I take Gujarat, or let me take some city, Ahmedabad, then I take Rajkot, and that's it. For this 1 2 3 4 5 6 7 8 let me, or state or cities I can call, no problem. Let me specify some abstract population. It is not important if it is correct or wrong. It is basically just for the sake of demonstration. Let me say it is 4779736, something just like that. 710326. The next, let me say 6393456. Then let me say 293980. Then for Chennai, let me say 589005. Then for Kolkata, let me say 898998. And Ahmedabad, let me say 192230. And for Rajkot, since it being a smaller state, let me say 89980. And let me specify some abstract murder rate, so that we have some values mentioned over here. Let me say for Hyderabad it is 5.7, Bangalore it is 4.5, the other one it is 4.3, then we have 3.2, then we have 1.2, then we have 1.1, Ahmedabad it is 6.7, and the last one I have got, let me say 7.9. And this whole of this data set, I'll save it maybe by the name of state on my desktop, because I can easily retrieve it. I saved it as state, save this file as a CSV file. No, not this. Where is my CSV comma separated value? So I save this by state desktop on my CSV as a CSV file. Now what I do, I go back to my R Studio. Have you drawn up this data set? You can give whatever values. Values are not important. We are trying to solve a problem. Have you done this? This is the most fundamental thing what we have to do in statistics, or what you have to understand. Have you made up this table, please? Can somebody confirm? Samir, Boliye, have you drawn up this? I save this, go back to my R. What I'll do, I'll read the data set. We know how to read it in R. It is read.csv. Let me give it a variable. I say state, state, give the assignment operator. I say read.csv. And within bracket, I have to give the complete path of my data set. So what I'm going to do, I'll just pause the screen, go back to my desktop, copy the complete path of this, because what is important for me is the complete path of my data set. Where is this file? I've saved it by the name of state. Yeah, okay, I've just found it. Let me calculate, find out the path of the file. And please do not go by the path which I have written, because I am running on a Macintosh. There will be definitely slight changes in what you write. So I will unpause this or presume this. I say this is my path, and it is state.csv. Now, in order to see that this is being read, I just call my variable state. And when I hit enter, it should list out my simple data set. Now comes to the fundamental thing that we have to learn. The first thing is we know correctly. I don't know who had answered. Was it Saida who told me how do you find out the mean? The sum of all the values divided by the total number of values. So to read, say I want to calculate the mean or average of the population. So what I will be doing, I'll say mean within regular braces. I say the name of the file, which is state, then squared braces, and I say population. This is it the same population? Argument is not numeric or logical. Okay, this says I'm not able to pull in because okay, this will be should it is fine actually. It is fine because it is population as a field in this, and I've specified the state dot population. It is one and the same, but it should give me my output. Yo, 1 second. What we will do, since I told Ray mean of the state of this population, is there what is the mistake in this mean of state of um, or do I have to remove the commas? I don't have to because I never put any commas in this. Let me check the data type of this, what I've specified for this column. Let me say it's numbers, no decimal. Yeah, fine. Save this, go back to my R, read my read my data, that is, yeah, read my data set. I say state, it tells me this is my data set. Then what I do, I say mean of my state um, of this population. It tells me the population, the mean of the population of the state. Now this population, although I have defined, I can trim this population. Basically what I want to do, say I want to trim it by zero point 0.1. You know what do you mean by trimming it, chopping it off. I can just specify mean of this state of my population, which I would say after the square braces, I would say, please trim it by zero point 0.1. So when I execute this, see what I get. Since there is nothing, no decimal places, it gives me the same. In the similar way, I can also find the median. How do I do? I say median of my state of this population. That's all. Kindly run this yourself for you to uh, see this and understand this better. Mean, median, whatever I want, I can specify in this. It will give me, since we are just calculating mean, trimmed mean, and median, I have just found mean, trimmed mean, and median. Nothing more. When we do mode, we will get into that. How do we find it out? Is this comfortable till here? Please tell me.
Yes, sir.
Okay. Now what we will do, I'll request you jump back to Jupyter Notebook. So when we go back to Jupyter Notebook, let's do it in Python. Let's see what will Python tell us or what will Python tell us how to do. Now in Python, have you opened up the Jupyter Notebook? One of you can tell me if you opened Jupyter. Let both the things be open parallelly because we will do in both of them, R as well as Python. Tell me please. Boliye, have you opened it?
It's opening, sir.
Yeah, fine, fine. And please let me know after you're opened so that we can do it together.
Ready, sir.
Okay. In
Sir, we are
Python, how am I going to? Yeah. Thank you. In Python, what do I need to do? I need to read a CSV file. I have to say pd.read underscore CSV. So what I need to do, I have to import pandas as PD. Then let me give it a variable, say state. I will say state is pd dot read underscore csv with the complete path of the file. Now, in order to do the path of the file, in R as it is, I've copied the path, the same path I'll copy it. It is exactly the same because the file rests at the same place. So I come back over here, uh, copy the complete path over here.
12 hours.
And when I call back my state, it has to list out the data set for me, or this data set which resides at my desktop. This is the data set of mine. Now, to find out mean, the first one we are finding out mean. The syntax of this is more or less the same how you did in R. I'll just say state of this population, which is my column, and this I'll say dot mean open close braces. That's it. Execute this. This tells me this is the mean. Now to find the trimmed mean, what will I do? Let me specify it as trim mean of the state express. Can you kindly mute your microphone, please? Yeah. And my column, I'll express it. Always columns have to be expressed in square bracket within inverted commas, and commencing Python 3.5 and above, whether single or double inverted comma makes no difference. So I say population, and I specify the trimmed amount, which I say, let me say 0.1. When I execute the, okay, trim mean, basically what I have to do, I have to import trim mean. Or you can say, you can, no problem, you can do one thing, you just say mean of the state of this thing. It should, see, you need to import trim mean. Or what I'll, not trim mean, it's a part of statistics, so I will import statistics, say as st. So I'll say st dot trimmed underscore mean is this one. Statistics and nothing. Okay, let me import, it's a math, no problem. Trim mean, fine, don't worry about this. Now to find the median, we know it is pretty simple. What do? I say this state of this population, I'll say dot median open close brace, and it will give me my median of this. It says 649,666, whatever this value. Okay, this is how do you find out the median, and this one of this population column. Now let's do one thing. Let's go back to R and find out the same things, or do some statistics for this murder rate. We have represented murder rate as murder space rate. What we will do, we will go back to the data set. Let's specify it as murder underscore rate. This will otherwise give us trouble. The space gives us a lot of trouble. So we have specified it as murder underscore rate. Now, before you begin anything in R, I will want you to install a package called Matrix Stats. So please go to install, type Matrix Stats. See, it comes up on its own. It says Matrix Stats. I will install this package Matrix Stats, which maybe few seconds it would take for me to install this. Thereafter, run the library function. It is, I am importing it as part of the CRAN library. It has imported. I would run the function library of matrix stats. Let it take effect. Fine, it has taken effect. Now what I do, this is important. I'll tell you why is it important. We need to do some computation for which we will require this. So after having imported, can I take it that you have imported this metric stats? Tell me please.
Yes, sir.
Okay, let's calculate the weighted mean and weighted median. We know what is weighted mean and weighted median by definition. So let's see how R helps us. I'll say weighted dot mean of my state. With this, let me use this murder rate. Murder underscore. No, before this, I have to read the package because I have modified the package. One second. So I go back into the syntax of R, which reads this, because I want my data set first to read it. So now when I say state, it says murder underscore rate. Now I calculate the weighted mean of this state. I want to calculate the murder rate. So what I will say, murder dot rate. And let me say murder, yeah, murder underscore rate. Murder underscore rate. And after the square braces, I'll say let W be the state of this population. So when I execute this, it says, okay, it is not found. See, weighted mean is a part of this library metric stats. That means I'm not able to import my metric stats properly. That's why it's telling it's not. Could anybody execute this? Could anybody execute this function weighted mean? See, it is just because it's not been imported properly. That's all. Absolutely no other rate, no other reason. Has anybody been able to execute this weighted mean of the state of murder underscore rate and comma W equal to state of this population? It is only the problem with installation of this metric stats. In the similar way, you can even find weighted median, for which what you do, you just say weighted median, weighted median of the state. Yeah, it tells me this. I'll tell you what could be the reason. The weighted mean, yeah, it will be this weighted mean. Now it should give me weighted mean. Yeah, 4.85. That's it. Small little typographic error. So were you able to calculate the weighted mean and the weighted median? Tell me please if you have been able to do it. हो गया आपका? Are you able to do it? Kindly do not remain silent.
Yes,
I do
sir.
not know what it is. Yeah, okay. Now, after this, let's enter into another one good area where we need to measure the estimate of variability. So, minute I say estimate of variability, there are some key terms which you should know, and I'm sure you know it. This is something which is taught during the school days of what is deviation and what is variance. Can you tell me how do you define deviation? Boliye, please. At the max, you don't know, tell me, I don't know. Tell me, bachao, we will help you out. Okay, deviation is nothing but the difference between the observed value and the estimate of location. That is, deviation is the difference between the observed values and the estimate of location. And variance is the sum of squared deviation from the mean divided by n minus 1, where n is the number of data values. Once again, variance is the sum of squared deviation from the mean divided by n minus 1, where n is the number of data values. At this time point, you might think, why should I learn R? Please understand the extreme importance of R is whenever during your course of engineering you learn on the concept of artificial intelligence, machine learning, and deep learning. Definitely, I would say, because as on today, I have conducted more than 800, 900 hours of session, not this regular teaching, apart from regular teaching session in India and overseas. Whenever you solve any problem in machine learning, you have to do it using four different techniques for you to understand the inside out of it. That is, the first, solve it mathematically, all algorithms. Second, solve it using Excel. Third, solve it using R. Fourth, solve it using Python. Once again, under Python, you will have to do it in two different ways. What I have seen, more than 95% of educational institution in whole of this country solves it using Python, using the fundamental libraries, that is NumPy, Pandas, and Matplotlib. Maybe little bit of TensorFlow here and there, but that is of no use, and nobody in the industry requires that. Till the time you are in an educational institution, you are happy, your faculty is happy, your college is happy, all are happy. But the minute you step outside, you get a heart attack, because that is not the technique what somebody wants. Everybody wants you to learn the advanced techniques or the advanced libraries of Python. You might feel Python as on today has got exceeding 1,35,000 libraries. How will I learn 1,35,000 libraries? Don't worry. As a specialist in BDA, you just need to learn 21 libraries. That's all. But to learn 21 libraries, you need to be crystal clear with the fundamental libraries, which is NumPy, Pandas, and Matplotlib. So kindly brush up, and that is what is the importance of learning R, which I said. So, apart from these key terms for variability, which I said, deviation and variance, there are few other terms which you should know what it is. Then a standard deviation, which is nothing but the square root of variance. Then you got MAD, which is mean absolute deviation, which is nothing but the mean of the absolute value of the deviation from the mean. Then you got median absolute deviation from the median, which is nothing but the median of the absolute values of the deviation from the median. Then you got range, which is the difference between the largest and the smallest value in the data set. Then you got order statistics, which is nothing but the metrics based on the data value sorted from smallest to the biggest. Then we spoke on this percentile, which you know, which is the number of values which are below a certain value. Then is a very, very important term which I will write for you guys on your screen, which is what is called as IQR, which is nothing but interquartile range, which is the difference between the 75th percentile and the 25th percentile. Keeping all these things in your mind, let's do what is it in R as well as in Python. What is this? But before you do that, you need to understand on another very, very important term called degrees of freedom. See, whenever you learn, before I explain to you what is degrees of freedom, can somebody explain the same, or what is that you have understood on the degrees of freedom? Can you explain to me, please? Anybody? Bolia, anybody? No problem. At the max, what will happen? It might be wrong. No problem. Don't worry. Anybody? Syed, Sharmila, Shahab, Syed Wali, Conan. Explain. Anybody? See, in statistics, there is always some discussion on why n minus 1 is the denominator in the variance formula instead of n, which leads us to the concept of degrees of freedom. This, I would say that this distinction is not important, since n is generally large enough that it won't make much difference whether you divide by n or n minus 1. But in case you are interested, I would say this is the story. It is based on the premise that you want to make estimates about a population based on a sample. Now, if you use the intuitive denominator of n in the variance formula, you will underestimate the true value of the variance and the standard deviation in the population. And this is what is referred to as biased estimate. However, friends, if you divide by n minus 1 instead of n, the variance becomes an unbiased estimate. Did you understand, or do you want me to repeat it for you? बोलिए, please tell me. Anybody wants me to repeat it or we continue? Considering that you have understood this,
Yes, sir.
don't be
Continue.
silent, please. How will I know? Yeah. So after having seen this degrees of freedom, we will say on the, or we will make a small little mention on what is this MAD from median. That is median absolute deviation from median. For to calculate the median absolute deviation from median, the mathematical formula is something like what I write for you on the screen. I would say this is median of the braces of some entity. And what is this some entity? It is the absolute value of x1 minus m, comma, absolute value of x2 minus m, and this so on all the way till xn minus m. Here m is the median. Like this median, the MAD, that is median absolute deviation, is not influenced by extreme values. Kindly remember this. It is very, very important for you when you do anything in R or thereafter in Python or anything. Now, what we will do, we will see the variability estimates of some population. And for this, once again, let's take the same data set what we had taken of state, population, and some column as murder rate. So considering this as my data, I go and we will calculate some variability estimates of this. But please understand, all of you, what we are doing estimates. Like if you remember, many a times I told you, you have to learn just 50 statistical techniques to be wonderful in BDA. We have started off right from basic ground level, that is ground zero, so that you understand what these things are. So the first thing what I will do, let's calculate a standard deviation of this. Before I calculate standard deviation, let me read the data set. I will pull in, I'll just copy the same thing because we have already read the data set. This is my data set of state, population, and murder rate. We know how to calculate, let me calculate the standard deviation of this column population. We very well know how do we calculate it. Standard deviation, I just write SD. And of what? Of my this state. And what is the column I want? I write it in inverted comma, population. So when I just hit enter, it tells me what is the standard deviation of this population. In the same way, I can also calculate the IQR, interquartile range of this column population, for which I'll just say IQ. It should suggest to me what it is. I say okay, IQR of, yeah, it tells me it is IQR. IQR of the state of the column population. So when I do this, okay, it says error in quantile as na.rm names false, object cannot coast to itself double. Okay, it says I am not able to do it. Why? Because we have missed out on one square brackets. How can we miss it out? I say it is double squared bracket. Now when I do, it tells me IQRS, whatever this value, 1600640. Then we can also find the MAD value, that is median absolute deviation from the median, for which I'll just say MAD. It tells me MAD is there. Don't, and my suggestion to you, when you use R, unlike Python, don't try as far as possible not to write on your own. Let R suggest it for you. Then you would be very, very correct. I would say of population. Minute I do this, it tells me the median absolute deviation from the median is 602766.6. Are we comfortable till here?
Yes, sir.
Please tell me, are we? Yeah. Let's now go back to Python. Go to the Jupyter notebook. When I start off with this in the Jupyter notebook, I have to from I have to stats models. I will import uh, robust dot scale dot mad. Let me run this. Fine. One second. Once. Just 1 second, please. This phone of mine is ringing. Just a sec. Okay, fine. What I will do, we will use this function robust dot scale dot mad from this stats model package. I'll say wait 1 second. From stats model import, or I'll say import stats model. Let's import the whole of the stats model. Import stats model. Whole of the stats model. Let's import. Oh, smash model dot API as, let me say, SM. There is no package stats plus. Oh, it is not stat, it is stats model. I'm sorry. There's nothing stats models. Ah, my mistake. Yeah, it's fine. So it should be fine. Stats models dot API as SM. Fine. Now what I will do, from this stats model package, we will use this function robust dot scale dot mad. So I say, let me write it. My state of this column, my population of this column population, I just say std, open close brace. It should give me my standard deviation. Now to find out the IQR, interquartile range, I have to specify the quantile value. So let me say state of my population dot quantiles. Quantile, let me say 0.75, 75%, because quantile is difference between 75 and 25%. So quantile 75 minus the state of the population column of the state dot quantile of 0.25. So when we run this, we should get my IQR, interquartile range. Then after this, what I do, I have to find the median absolute deviation from the median, for which I'll say, uh, sorry, let me delete this, yeah, execute this, go back, yeah. Now I would import the function robust dot scale dot mad of my state, and for this I want my column population. So when I run this, robust is not defined. It is not able to pull in this library. No problem, don't worry. It is not able to find out the mean absolute deviation of this. It's fine, don't worry. See, here you will, this is the way how you find the standard deviation, and you can say this IQR. Now, what you need to do after you get all this data, you have to explore the distribution. Exploring is basically, can you mute your phone, please, Sadaf? Sadaf, can you mute your microphone, please? Yeah. When you explore the distribution, you create various things like box plot, frequency table, histogram. You know what this box plot is. Box plot is a plot to visualize the distribution of data. You have even got frequency distribution, which is a tally of the count of numeric data values that fall into a set of interval, which is bins. Then can you mute your microphone, please? We have all these stray noises. Then we have got this histogram, which is a plot of the frequency table with the bins on the x-axis and the count on the y-axis. Then we also, in order to explore the distribution, we can also use a density plot, which is nothing but a smoothed version of the histogram, often based on KDE. KDE is kernel density estimate. So, in order to find out all these things, let's take a jump back to R with the same data set. If I want to display some percentile of the murder rate by the state, so I will be using the quantile function in R. I'll say quantile, it tells me, and I say of the state, I want the murder rate to be taken. We had written murder rate as MUR, murder underscore rate. I want the murder rate to be taken, And after my square braces, I will use something called as P, which I would say is nothing but using the character string or the constant string. I would say 0.05. Let me specify the C value. How many readings I've got in this? 8 of them. That I have to specify 5 values because I need the output as at 5%, 25%, 50%, 75%, and 95%. So 5% I write 0.05, for 25% I write as 0.25, for 50% I write as zero point 0.5, then for 75% I write as 0.75, and for 95% I write as 0.95. Now, when you execute this, it tells you what are the quantile values at 5%, 25%, 50%, 75%, and 90%. This one, could you do it yourself? Tell me, please, if you've done it. Somebody, please tell me if you're done. Let's proceed ahead with what we were doing.
Done, sir.
What we will do, yeah, we will do the same thing or try it out doing the same thing in Python. To do this thing in Python, what will I say? I'll say state of murder underscore rate. I'll use the quantile function. Quantile, and I specify the various quantiles: 0.05, 0.25 for 25%, 0.5 for 50%. Can you mute a microphone, please, Sadaf? Kindly mute a microphone, Sadaf Nas. And for 75%, I would write 0.75, and for 95%, I write 0.95. So this one, when we exit, oh, I have to, it's not finding murder rate because let me read this data set. That is the reason. I read the data set, fine. Now I write the same thing what I have written over here. That's it. I get it. It has told me at 50% 1.135, 25 sorry 5% 1.135, 25% 2.7, 50% 4.4, 75% 5.9, and 95% 7.4. These are the various quantiles which I have got. Now we said in order to could you do this still here? My sincere advice to you is please do this. Very, very important for you. All these things, what we are doing. Because you would never get an opportunity otherwise to do all this before you hit your workplace. And like what I had assured to your principal and your HOD, definitely, if you perform well in this, I'll take you along with me for internship, live internship, and you're good. I will offer you a job at Sultanate of Oman. So please prove it to me that you're good. Okay, the next what we do is we do create box plot. We know box plots are based on percentiles and it gives a quick way to visualize the distribution of data. So in order to create a box plot, let's start off by creating it in R. I go back to R. To create a box plot, I use the box plot function. I say box plot of my state. I want to create a box plot of this population. I say, so in single inverted comma, I say population. Let me do one thing. Since the number of this population is very, very high, I'll divide it by 3 4 5 6. Yeah, that should take care of this. And I specify my Y label, which I say, let me say, is which is my population in millions. So once I specify my Y label, then what is left? I have to close my inverted comma. So there is double inverted comma put up over here. Let me delete it. I close my inverted comma, enter it. I have to get a decent enough box plot, which you find over here. This is the box plot which I get. Isn't this wonderful? I have specified only my Y label. Don't worry, we will, all these coordinates, labeling, we will do it later. No problem. Could you get this box plot? Tell me, please.
Yes, sir.
Small, small. So could you create this box plot? Hello.
Yes, sir.
Okay.
Yes, sir.
Wonderful. 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 Can you hear me? Who spoke? Whoever spoke.
Yes, sir.
Yeah, fine. Now what we will
We
do
can
the
hear you.
same thing in Python. Let's see how Python is going to help me out. I hope you are able to hear me. You are with me here. Shahab, Sheikh Sadullah, can you hear me? Somebody speak out, please.
Yes,
Silent.
sir.
Yeah,
We
fine.
can hear you.
In Python, what is that I'm going to do? Just for the sake of convenience that this data is being read, I'll pull in this data, execute it. Thereafter, what I'll do, I'll create a box plot in Python for which I say AX equal to state of this population. This whole thing, let me divide it by 1 underscore 3 zeros underscore 3 zeros. I divide the population this way. Then I say dot plot dot.
अरे सर तुम लातेज केक खाते सुबह खाना नहीं खाए केक खुला रखे माइक मैं कितने खाया नहीं
Yes, sir.
Yes, sir.
Sir, even I am not able to hear, sir.
Hello, can you hear me?
Sir.
I can hear you now, sir.
Yes, sir.
Yeah, that's fine. There's some problem with the connectivity. I'm sorry. Can you see this Jupyter notebook in front of you?
Sir.
Okay. See, I said the important thing for you as BDA, big data analyst, is what you infer from this graph, not what you plot the graph. Plotting graph is maybe Python programmer ka kaam, not your work. So you tell me what is that you infer from this graph? What are your inference? Sayeda, can you help me out with what are the inferences? Inference which you draw from this plot? Once again, you gone silent. I really don't know. आप लोग हो कि you got disconnected. Tell me, are you there or not? First, tell me that.
Yeah.
Yeah, okay. See, we can see that the median state population in this plot is around 5 million. That is, half the states fall about half the states fall between about 2 million and about, say, 7 million. And there are some high population outliers in this. The top and bottom of the box of this box plot are the 75th and 25th percentile respectively, and I would say the median is shown by the horizontal line in the box. That is the median. And the and on top of the box, what is there on top of the box is it refers to the whiskers which extend from top and bottom of the box to indicate the range for the bulk of the data. That is what you infer. Once again, see, the very important thing for you is your inference, what you draw out of this plot. The inference is, you can see that the median state population is about, you can say, around, say, 5 million. And half of the states fall between this population of, say, between, say, 500,000 to 2 million. And there are some high population outliers in this, which you see these small circles on top. The top and bottom of this box are the 75th and 25th percentiles, and the median is shown by the horizontal line in this plot. So is this clear till here? Please tell me. Yes or no?
Yes, sir.
Okay. Now, what we will do, the next thing, let's draw some more inference out of this data set. For which I'll request you, let's go back to our R. Our friend R is waiting for us, which you see on the screen. Let's plot the frequency table and draw the histogram. We know a frequency table of any variable, it divides up the variable range into equally spaced segments and tells us how many values fall within the segment. So what we will do, once again, the frequency table of any variable, it divides up the variable range into equally spaced segments and tells us how many values fall within each segment. So what we will do, we will write some command or syntax in R for it to draw up the frequency table for us. What is that we need to do? Let me say, I will once again, since we are starting off from this, I will start off by reading the same data set. That is what we have written over here. That is state, giving it a variable name state, and call my variable state, which gives me my original data set. Now, I would define a variable called breaks, which I will assign it to form a sequence, and I will say from minimum of this state and take my, we are taking this column population, and this one uh, from this value, oh sorry, I would once again have to write this. From this value I would say to my max value, which will be of the state of my population, the column, and this value to this, and I also have to specify what is the length. So I say my length, I would take it as, let's say, 11. I close my brace. Is it there anywhere I missed out on any braces? It will give me trouble. Let me execute it. And now what I say, I would have to say that please, I have to specify the frequency of these breaks. So I use the variable pop underscore frequency, which I say, please use the wonderful function of cut to this data set state, where I will be choosing my population column, and definitely I'll have to specify my breaks, which I say breaks equal to breaks, and I specify my right. I want to find the frequency with effect from my right of my data set. I say right is true, and I'll say please R also include the lowest, for which I say include lowest also as equal to true. So at the end of this, when I run it, it says fine. And then I tell my R, please tell me the table of this pop underscore frequency. This is the table for this frequency table. Also, you can view this table on the right hand side, top right hand side, which is find pop underscore frequency. Just double click this. You will have the table being displayed. Just select this, double click it, you will have the table being displayed out for you. Okay, so sorry, this is for the data. Data, you click, see the data comes over here, and this is the prophecy on its own. See, I just click on the state, this double click on the state, the command on its own, it comes view of state. It tells you what this data set is. And this is the table which I wanted to draw, which I've just drawn it out for you, the frequency distribution table. Now, please, after you do this, you have to help me. You are wonderful students, very good students. Please help me. How do I do it in Python? Have you done this in R, which I have written? Please tell me if you have done this, what I've done in R, if you have done it. What happened? Or is it that you got again disconnected? Are you people here or you got disconnected? There are only a few names I can see: Sheikh Saidullah, Shayad Asif, Sayed Wali, Sayadash, Shamaila. Please tell me if you can hear me and you have written this, what you have written in R.
Done, sir.
Done. The same thing we will try doing in Python. Can you tell me which is this function of Python which I'll be using to create this frequency table and histogram? I will be using the pandas.cut function. This pandas.cut, it creates a series that maps the values into the segments. Then I will use this method value underscore count to get the frequency table. So in order that we are with the same data set, although I don't need to do, making it more comfortable, let me read the data set. This is my data set. Now, what I will do, I use a variable called bind population. For this, I will use the wonderful function of Python called pd.cut. I want to cut the state, but within the state, I want the population column to be cut. How? I specify 10 values. Then what I do, I tell my friend bind population. I tell, please do a count of what you have cut. I use values underscore counts. So when I execute this, it gives me my frequency distribution table. This is my frequency distribution table. So I have done it in R as well as in Python for you. Now comes, if you have done this, let's go back to R. Done?
1 second, sir.
Yeah.
Yes, sir. Done.
Done? Great. Few more seconds we wait before we take off to back to R. Now what we need to do, we have created the frequency table. I have to plot a histogram. And what is a histogram? Histogram is a way to visualize the frequency table where we have got bins on the x-axis and the data count on the y-axis. How do I do it in R? Go back to R and tell my R, please plot a histogram. I'll use this hist function of what? Of this data set state, calling my population column. And I would say, please provide breaks in what you plot. I say breaks equal to breaks. When I execute this, I should get a histogram. A beautiful histogram I've got. Now you will have to help me as to how do I do it in Python. Don't worry, whatever doubts you have got, whatever kind of query, you can ask me whenever you want. Or what we will do, after tomorrow's session, we give you a half an hour window. You can ask me whatever you want, whatever doubt or whatever query you got, or worse come worse, you can drop a mail to me. We will definitely answer you back. So have you created a histogram using R, like what I have done?
Yes, sir.
Now what we do, go back to Python. Can you tell me, Saida, how do I plot a histogram in Python?
No
Just
idea,
that,
sir.
yeah, okay, just that we don't confuse it, I'll call this data set so that we know it is this data set we are dealing with. I will call a variable called ax. I will say for this state, and within this I want my population for which I want my histogram to be plotted. So I say this population divided by 1 underscore 3 zeros underscore 3, that is per million. I close this and I say, please plot a histogram for me. How do I want? I have to specify my figure size. which I say, let me give it as 4 comma 4. And now what I do, I set label for my plot. I say ax dot set underscore x label of, and let me say I give the label as population in millions. That's it. When I execute it, we have to get a good and very good histogram. So this is my histogram which I plot in Python. And since, kindly tell me, did you have any structured course in Python or as a subject programming with Python? Saida, please tell me, did you have any subject as a programming in Python?
So we didn't have Python as a as a subject in academics.
Oh, it is very. And what did you have as a language? Was it Java?
Yes, sir. We had
Java,
Java.
C, C++.
Yeah, please understand Java is fading out from the industry. Even in today's Times of India paper, it is there the number one programming language in the world is Python. Python is going to eat up entire Java. And it is just a question of time. So we have plotted. So what I feel a prerequisite is you should have learned R and Python. And for all of you, I have absolutely no problem. If you are facing any problem with the syntax in Python or R, what I'll do, although it is not a part of this course, I can separately conduct a few sessions, maybe 10, 15 sessions for you separately. Absolutely. See, it is nothing in this world is on money. Don't worry. As a courtesy, I'll conduct it for you so that you learn these concepts of Python. You can approach me for that separately so that we form up a small group and conduct these sessions in Python for you. Now, after doing all this, what did we say? We said we have done this histogram, wonderful. Then the last thing what we need to do is to plot density plot and find out the estimate. Now, related to the histogram is a density plot. And before we do anything on density plot, please remember for you to excel in big data analytics, you have to be good in two concepts, which I'll request you please do a pre-reading so that you are wonderful with what we are doing. We have just started with BDA. When we go more deeper and deeper, you will find it of great difficulty because we have got some extreme high end topics like blockchain, NLP, natural language processing. You will get confused because we will be using extreme Python in that. So definitely brush up your knowledge on Python as well as in statistics and Excel. Please learn it yourself. If you have got any doubt anytime, don't worry, we are there to help you. I will help you out, but provided you reach out to me as a group, not an individual thing. It will be very difficult alag alag se to do for everybody. So we will plot what we said, coming back on density plot and estimate. See, related to the histogram is what is a density plot, which shows the distribution of data values as a continuous line. And a density plot can be thought of as a, you can say, a smoothed histogram, although it is typically computed directly from the data through the KDE, kernel density estimate. We said related to this histogram is nothing but a density plot, which shows the distribution of data values as a continuous line. And a density plot can be thought of, you can also think it of as a smoothed histogram, although it is typically computed directly from the data using kernel density estimates. So let's do one thing. Let's use R and plot a kernel a density plot. So to use R and plot a density plot, we go back to R Studio. So over here, I would say it. We said it is a smooth histogram. So I use the hist function. I would say hist of state, and here I want to take murder rate. I would say murder underscore rate and close my square braces. Then I say my frequency, I don't want it to be true. I say is false. Then I would say, then for this, I would say lines of this uh, density plot of the data set state, considering the murder rate as my column. I would say please specify a line with density. which I would say LWD as 3, and specify a color as, let me say, blue. So when I execute, there is a spelling mistake. It is not line A, it is lines. The first, it's a mistake from my side, it is lines. So when I execute this, I get a wonderful density plot. Please see on the right hand side, this blue colored line has come. This is the wonderful density plot what I've got. Now, can you help me on how do I plot it in Python? Have you done this? Have you completed this of this density plot? Tell me, please. Sheikh, Sadullah, Syed Asif, Syed Musa bin. Yeah, great. We go back to Python. Now we see what do I do in Python. In Python, what I'll do, I'll specify AX as my variable. I'll say my state of murder underscore rate, and I will say, please plot a histogram because it's a smooth histogram. And I say my density as true, and I specify the x limiting values. X lim, which I would say is between 0 to 12. And since it's a histogram, I have to specify the bins, which I will say is in the range of 1 to 12. Close my braces. Then I would say state of this murder rate, that is MUR murder underscore rate, of the state of this murder rate column. Please plot a density plot. So I'll say dot plot dot density with my AX equal to AX. Importance is this plot function takes an optional axis, which is AX, as the argument, which will cause the plot to be added to the same graph. This I have specified AX equal to AX because this plot function takes an optional axis, which is AX, which causes the plot to be added to the same graph. Now I would go ahead and set my label. I'll say AX dot set underscore X label, which I would say, let me say, murder rate. Maybe I say per um, 1 lakh or 100,000 per 100,000, and give it an inverted comma and close it. When I execute, okay, murder rate is not defined. I'll tell you why. It is not reading the data set. So I copy, I execute my data set. It reads. Now what I do, since murder underscore rate is being defined here, it should not be a problem. What I will do, I'll copy the same thing, set it over here, and here the correction is I have to put it in inverted comma, murder rate. So when I execute this, I will get a density plot, a wonderful density plot. I will request you, please spend some time, learn on the fundamentals of all this histograms, the entire statistics. I would say, please brush up with your knowledge on statistics. Definitely, it will help you in your journey as a big data analyst. Definitely, it will help you in your journey as big data analyst. Now, I will request you, have you drawn this density plot? Tell me, please, have you drawn this?
Yes, sir.
Okay. See, give me another 1 or 2 hours. I'll share the complete recording of this as a MP4 file with your HOD. So you kindly request your HOD to make it available on some public domain so that you can download it. It is basically the link and the password which this site tells me, which I'll share it with you. You can download, keep it with you as an MP4 file. So what we will do, we will stop for today since the time is up. Tomorrow at the end of the session, I'll give you extra half an hour's time for you to clarify all the doubts. But my request to you is, please brush up on all these concepts of statistics and Excel. And you have to be fresh where we start off tomorrow from here, this concept of density plot. You have to learn more on all these things. Is that fine? Kindly tell me if it is fine. Yeah.
Yes, sir.
Great. Please brush up on all your fundamentals so that tomorrow we are all together and we will start it bang on time. Why don't you join 2-3 minutes before time? Why do you want us to keep waiting for you? Please, if you can join before time, great for you. And I will share this recording maybe in an hour or two with your HOD. Thank you. Have a nice day. I'm rushing because I have got another meeting at 1 o'clock. Thank you, friends.
Thank you, sir.